Hey everyone, this is Scott Wilson coming to you live from Raleigh, North Carolina. I'm so grateful to be here with you today. Major shout outs to the 49th Security Division and UNC Charlotte for putting on this conference. If you get an opportunity to thank one of our conference organizers today, please drop them a little love in the Discord or Matrix channels. They've worked really hard to put this conference together. I am part of the X-Force Red team at IBM Security. We're the offensive security group. So my team is essentially a group of hackers, red teamers, purple teamers, and vulnerability management professionals. And we do exactly what it sounds like. We get paid to break into companies to help them identify their vulnerabilities and put together an action plan with them to resolve those items to reduce their risks. A lot of what I do focuses on vulnerability management, and I've prepared a talk for you today related to vulnerability management for containers. And so I don't need to tell you all that cloud security is kind of the new hotness and has been for a while and will be for the foreseeable future. And more applications are moving to a containerized business model. And that has a big impact on the vulnerability landscape, the attack surface of your organization, and how you need to go about addressing those vulnerabilities. So I'm going to talk to you today about a couple of things. So specifically, I'm going to share some terminology and some concepts to basically make sure we're on the same page with respect to what we're here to talk about today. Then I'm going to share a little bit about the development pipeline. What does that look like? If you listened to Will's talk earlier today, you got some good insight into the CI/CD pipeline, what that is, what kind of attacks are commonplace for that type of setup. And I'll speak a little bit more about that as it pertains to containers and the deployment of containers, and of course, keeping those containers secure and safe. Then we'll go into some different vulnerability scanning strategies. It's a little more complex than the traditional host-based vulnerability scanning methodologies that companies have used for 20 years. And I'll highlight some of those differences, and then we'll move into talk about what kind of products are available on the marketplace, what are their strengths and weaknesses, and how do you go about making a cohesive decision about which tool to use and under what circumstances. It would be difficult to talk about cybersecurity and vulnerability management without at least touching on compliance. And so I've got a few important points about compliance management in the container space as it relates to vulnerability scanning and management. And then I'll sum up with a couple of conclusions, and I've got a few takeaways that you can bring back to your organization to speak intelligently with your team about how to keep containers secure, how to do vulnerability management in that space. So first off, though, let me get a couple of things out of the way. This talk is not really a containers best practices talk. That is really another topic altogether. There are a lot of things that you can do from a best practices standpoint, such as putting in a process to sign containers, making sure you don't use root access, layering the images properly to optimize the deployment and runtime activities related to containers. That's not what I'm here to talk about. Really, we're going to focus on the vulnerability scanning, how vulnerability scanning needs to be set up for containers. Likewise, I'm not really going to talk a lot about orchestration. You can't really talk about containers without at least mentioning orchestration, and Kubernetes and tools like it are critical for the successful operation of container environments. I'm going to talk a little bit about Kubernetes admission controllers, what they are and how they can help within the pipeline, but I'm not going to dig like super deeply into that topic. And then finally, I'm not here to make a sale. Yes, I work for IBM. Yes, X-Force Red does have relationships with a couple of vendors in this space, but I'm not here to promote any one particular product, and I'm not here to get you to buy IBM services or anything like that. So let's hit on a few terminology topics, a few concepts, just to level the playing field, to make sure we're saying the same things. What is a container? Well, it's a lightweight, independent, isolated computing runtime that hosts an application. Containers were conceived to be highly portable and sort of like Java when it was under its early development. The concept was, hey, what if we could write a small contained application that is highly portable that could run anywhere with no regard for what kind of infrastructure the underlying hosting system is. And that's what a container really is all about. A container image is simply a recipe for what is built into that container. And so the concept here is you create a container image, you build that immutable unit of software, and then you deploy instances of that into your production environment. In addition to the portability, one major thing containers can provide is scalability. So you have an application, it needs some more horsepower. Well, all you have to do is spin up a few additional copies or a few hundred additional copies of that container image, and you've increased your capability to deliver services to an application or to a service. Now, when looking at how containers are set up and how they work compared to traditional virtual machine environments, you can see in my picture on the right here, virtual machines are essentially a way to share components of hardware across multiple operating system instances. And so you've got your infrastructure, there's a hypervisor layer that is really the meat and potatoes of what virtualization is all about. And that hypervisor allows multiple guest operating systems to share resources on a physical computing unit. And that's great. Containers is a little bit of a different animal because there really isn't a hypervisor. Instead, you've got some kind of a runtime. Most folks are familiar with Docker as a popular runtime environment. And the Docker layer allows you to run multiple container instances on top directly of a host operating system. And that's very powerful because you've been able to eliminate some of the components that cause a lot of churn and angst in the IT management space. More specifically, the guest operating systems themselves can be huge, typically many gigabytes in size. And so each virtual machine that you're running to support an application has a full copy of the operating system. And guess what? That OS has to be maintained, it has to be patched, it has to be backed up. It's not something that you can truly ignore. And by contrast, in the container space, the runtime environment is what provides the abstraction layer. So engines like Docker, Containerd, LXC, runC, Creo, these are all very popular runtime engines that serve the same purpose, which is to share the underlying host OS's capabilities with multiple instances of your container. So a container itself has tons of different layers. At the bottom, you've typically got a bootable file system or a kernel layer. On top of that, there's typically a parent image, and that can be a full operating system, traditionally Linux, or it can be a very slimmed down and bespoke custom created operating system. And then on top of that, there's an application layer, and this is where you'll find things like your MySQL database or your Nginx web server and code like that. And then on the very top, there's often a writable file system for things like logs, access control information, temp files, and things like that. And the bootable writable file system usually is destroyed once the container is destroyed. So you've got many layers kind of working together in concert. This colorful picture here represents kind of the 4Cs model of container security. So you've got the cloud environment on the external layer, meaning what's the security of your data center like? What does that look like to you? And then within that, you've typically got a cluster, which is a family of computing resources to support the container environment. Inside that, you have the container itself, and then of course your code running down at the bottom there. And this presents a lot of challenges because the attack surface can actually be very large if these containers are not managed properly, if they're not put together in a cohesive way, or if the underlying cloud and container infrastructure is not properly secure. So there's a lot of things that can be done here to look at the attack surface, to minimize that, and we'll talk about that in a minute. I just got done saying I wasn't going to talk about orchestration, but just so that we know what we're talking about here. Orchestration is the capability to manage multiple container resources. And Kubernetes is the easiest example to talk about, but there are other tools out there like Docker Swarm, Apache Mesos. There are a lot of different platforms, although I would say Kubernetes probably gets the most attention in terms of its popularity. And the purpose of orchestration is to provide a couple of different functions. Certainly service discovery and load balancing is a key component. The orchestration of different storage components. I mean, these containers have to be written to disk at some point. And so Kubernetes and tools like it help manage where these devices are, where these containers are stored, and how quickly they get pulled in and out of production. Things like automated rollouts and destruction of containers once their life cycle is over is important. Automatic deployment is a key feature of orchestration tools because the idea is to kind of ramp up or bring down the number of containers as demand increases or decreases for your application. Kubernetes and engines like it also have the ability, I call it like a self-healing capability. So if there is a container that for whatever reason isn't performing correctly, or if it crashes, engines like Kubernetes have the ability to take that container out of circulation and replace it with a fresh copy. And the idea here is to maximize uptime, maximize service availability, and to generally take people's hands off the keyboard with respect to the minute-to-minute maintenance of running containers in the production environment. Let me talk a little bit about the development pipeline. So Will gave us some good information about that this morning, and what I'm going to say might differ a little bit. Remember, this is just a model. So the continuous improvement, continuous delivery pipeline is a good model that most development organizations use related to planning, building, deploying, managing, testing, and operating their containers out in the real world. So the, the planning phase of this is more about defining requirements, identifying what your scope is going to be, figuring out which software libraries, frameworks, components are going to go into your software product. Coding is pretty straightforward. Throughout the build, test, and release cycle, you're incrementing releases, you're putting together different use cases and test models and things like that, maybe going through UAT and other unit testing. And then eventually you get into release, deploy, operate, which is, hey, here's my code, it's ready for the world. Let me put this out into the production setup. Let's make sure it gets there, and let's operate it over time, making sure that the life cycle of that software is appropriate. So nothing you haven't heard before. I'm going to draw a little bit of a different picture of that to talk specifically about the container management pipeline. So I've simplified this CI/CD model a little bit into 4 blocks, if you will. So there's the development stage, which is a lot of the CI/CD stuff I just spoke about. The registry, or the second phase, is a really crucial concept to understand with respect to vulnerability management. The registry is sort of like a repository for your published code. It exists in a space that is before production occurs, and this is from where your orchestration engine is going to draw copies of your image to create and build and deploy a running instance of that container. The runtime, as I've said already, is kind of where the action happens. The runtime engine is what is responsible for maintaining that container, keeping it active, ensuring that it functions correctly. And then at the end, you've got your master node, the host on top of which all of this stuff runs. And it's important to not forget about that phase, because you still have to consider traditional vulnerability scanning, vulnerability management, and all the fun stuff associated with patching and backups and compliance and all that good stuff. I kind of think of the development phase and the registry component as more of the pre-production environment, whereas the runtime and the cloud environment, your master nodes and hosts and things, that's really like the production setup. And there are a lot of tools that are used throughout this 4-step phase. So you've got tools like Jenkins, Bamboo, and GitLab in the development space. Registry tools include things like JFrog Artifactory, Red Hat Quay, Amazon's Elastic Compute Services, Docker Registry, things like that. And then the runtime setup, I mentioned Creo, Containerd, Rocket, LXC. There are a ton of different runtime capabilities that help you manage containers. That's not an exhaustive list by any stretch of the imagination. The last time I looked, there were some 30 or 40 different tools just available in the commercial space. And that doesn't even include things such as open source technologies. So let me enhance this picture just a little bit. At the top, I'm sort of showing you once again the difference between development activities and production activities. But along the bottom, I've sort of feathered in here this concept of DevOps or DevSecOps. That's really the process associated with moving software from the CI/CD pipeline into the registry and ultimately into runtime. And it happens in a circular fashion. Orchestration, again, some of these tools like Azure Kubernetes Service, Apache Meso, Docker Swarm, all of those tools have the ability to reach deeply into the registry to pull images out to get them ready for deployment. And they talk to the master node to ensure that resources are spread out properly here. And so what I want to say to you here is that all of these four pipeline phases introduce an opportunity to scan for and identify security vulnerabilities. And there are tools that fit into each of those puzzle pieces. So when you think about vulnerability scanning within that pipeline, it's important to understand, well, what tools and systems does our organization use today? A very important component of that is what CI and CD tools are you using now? What system do you have in use as a registry today? Do we have the capacity for a staging registry? I'll come back to that topic in a minute, but a staging registry is essentially a copy of the traditional registry system that allows you to separate kind of a pre-production workspace for creating and posting images compared to like a final production ready registry that has the completed and supposedly secured images that you have built. And knowing all of that is critical to figure out what vulnerability scanning tool you need and will work in your environment. Many organizations put a premium on open source technology and they want to ensure that they're using an open source software product. But then again, there are a lot of powerful commercial tools out there as well. Budget obviously is going to come into play associated with that. And it's critical to know, well, at what phase of this container development pipeline do I really want to focus my security efforts on? That's going to have an impact on the tool and the methodology and the strategy that you ultimately select. I like to tell organizations to think about shifting left. That's not a term I made up, but what that means is kind of moving your security efforts further to the left of the model that I shared, meaning if you can get as close as humanly possible to the development and coding aspect of your process, the better off you're going to be. If you wait until you have code in production to do vulnerability scanning and to try to apply security fundamentals, ultimately that's going to cost you more and take more time and effort to fix those items. If you can nip it in the bud, perhaps at the beginning of your development process, you have a much better opportunity to make corrections more cheaply and more rapidly, which will benefit your organization. So now let's talk a little bit about the different vulnerability scanning strategies that you might want to consider. Really, the first thing that is important to talk about related to vulnerability scanning strategies is reducing your attack surface. Well, what does that mean? Well, your attack surface is simply the set of points on the boundary between all of these interconnected software components. And they represent points during which an attacker might be able to probe and prod and find a weakness and exploit your application or access your data or cause unanticipated consequences. And so it's really crucial to remember that you're responsible for everything you deploy out into the cloud. And so you want to try to minimize your attack surface, which means making your container images as small as possible, using the minimum number of management tools and software libraries and resources that you possibly can to ensure that the number of problem areas is minimized. So the idea here is if you can put out single purpose containers, if you can get rid of some of the default binaries and packages that come with your software, that libraries that you're using, that's better for you. You may want to take advantage of distroless images. It's very common today in the container development space to use what's called a distroless image, which is essentially a stripped down operating system that doesn't have any of the typical management tools and components that you might expect on a full-blown operating system. Many times that means actually removing things like a user shell or a package manager. And I'm going to touch on why that might not be a great idea in just a few minutes. But the idea here in terms of reducing the attack surface is making containers as small as they possibly can be, which will result in fewer vulnerabilities, and ultimately you'll have a smaller attack surface, and that's a good thing. I love the MITRE ATT&CK framework. If you're not familiar with that, on my slide here at the bottom, I've got a link that will take you to a live version of the MITRE ATT&CK matrix for containers. MITRE ATT&CK is simply a common vocabulary that is used to describe and explain different techniques, tactics, and procedures that malicious actors will use in terms of attacking different infrastructure components. MITRE started with this a few years ago by putting together TTPs for common operating systems, and they've quickly evolved into more specialized areas. And I love this containers matrix because it can highlight for you as a security professional where are the likely points of attack for a containerized development environment. This can help you kind of plan for the minimization of different security vulnerabilities conceptually so that you can pivot into using tools to help you identify some of these weak spots. Again, check out the link at the bottom here. It's really great information. If you've not visited the MITRE ATT&CK website, the cool thing is that this little matrix is kind of like a live action thing. So you can click on different concepts related to execution or persistence or credential access, and that will explode into a different view that gives you a lot more information about what you're reading. So what are the, hey Scott, what are the vulnerability scanning strategies that I need to understand? Well, there are a couple of different ways that you can go about doing this. The first strategy is to scan software within the development or build time cycle. And so, as I mentioned before, shifting left or pushing as close to your actual development work as possible is your best option in terms of identifying security vulnerabilities early. So move towards the CI/CD pipeline as best you can. The idea here is to scan your software for vulnerabilities and ensure that you're only putting clean software into your registry. That's an important step. You don't want to deploy junk to be out in production. The bad news about this particular scanning strategy is that it interrupts the workflow. So think about that for a minute. You've got your software coders, they're putting together software, they're building, they're committing, they're taking steps to get their code ready for deployment. You're going to call a timeout on that and say, well, hold on a minute. I want to scan your software for vulnerabilities. Let's make sure it's clean. And oh, by the way, wait for me to generate that report and I may be getting back to you with some things you need to fix. Not bad, but it's going to interrupt the workflow. And so there is a cost associated with that in terms of your development lifecycle and the time it takes to get code ready for deployment. The second scenario, though, is absolutely by a long shot the most popular strategy that I'll share with you, and that is scanning in the registry. So if you remember what I said about container registries, these are basically holding systems, holding cells for your finished container images as they are ready to be pushed out into deployment. So your orchestration engine will talk to the registry and say, hey, I need a copy of a web server. Okay, give me that container image and I'll make copies of it and roll it out. So your registry is really a great opportunity to scan for vulnerabilities for a couple of reasons. You can do those scans kind of any time. So it's an asynchronous capability, which doesn't interrupt your development shop. It allows you to kind of scan as often and as frequently as you want to. And you can rescan images as new vulnerabilities are identified and introduced, which is great. Because this is such a popular strategy, you're going to see in a few minutes that it has the best tool coverage. So almost every container scanning tool that I'll share with you today has the ability to integrate with the systems registry. And it's because it's such a valid place to do that work. I mentioned a bit ago about staging registries. This is something that we're starting to see much more common out in the real world. And so the idea here is that you take your registry system and you basically have a copy of it. So there's a staging registry and a production registry. And the idea here is you want to put all of your candidates for container images into the staging registry, scan the heck out of them like crazy in a repeat fashion. And then only once you are confirmed to have a good image, you feel comfortable that you've eliminated all of the security vulnerabilities, then you can copy that container image into your production registry. And from that production registry, either manually or through orchestration, you're ready to deploy that out into the production world. And this gives you a distinct capability to kind of separate some of the security and management functionality from the deploy and operate capability that I described before. So we're seeing it become more and more popular. As you might expect, larger organizations are adopting that model first, but I predict that it's going to become much more pervasive as the years go on. The third scanning strategy I'll talk about is runtime scanning, which is something you can probably anticipate very clearly what that is. So that just means scanning your running containers. And there are a lot of tools available to do that. One advantage of scanning your runtime environment is it actually gives you the best visibility into, hey, what vulnerabilities do I have right now that I need to care about? What is in my production environment that could represent a risk? Um, it's also a good strategy to employ if you're concerned about container drift or rogue copies of containers. One of the principles of containers is that they are immutable, meaning that they're unchanging images. But as I described for you several minutes ago, almost every container in use these days has kind of a writable layer, if for no other reason, to serve as a scratch area for things like logs and temp files and stuff. So they're not really 100% unchanging. And as a result of that, we've seen some organizations at IBM patch running containers or try to update packages on running containers. And what happens there is you start to get different copies of the same container, but they're not all the same. And that introduces a level of risk. So by scanning your containers in the runtime environment, you're getting the best view into, well, what vulnerabilities are here right now that I need to be concerned about. A challenge associated with this strategy is that each organization has to figure out, well, what exactly is my threshold? When do I need to act and when do I need to not act? For example, you might say to yourself, well, where we're going to draw the line is we want to make sure we have no critical and high vulnerabilities. And that might be good enough. Some organizations, specifically if they are under heavy compliance regulation or if they're a government entity, they may say, hey, you know what? No vulnerabilities are acceptable to us. We need to make sure that we can't identify any weaknesses in these containers. So in terms of prosecuting vulnerabilities, your group, your company, your org has to decide, well, where are we going to draw that line? And then finally, an advanced strategy is to use something like Kubernetes admission controllers. Admission controllers are a topic that I'm hoping to do a lot more research on in the future. But Kubernetes basically provides a very powerful API-driven interface to your container space that lets you apply certain decisions and logic to what's happening with your containers. And what I mean by that is you can write a Kubernetes admission controller that says, if I detect a running container that has X number of vulnerabilities, we'll pull that out of circulation or destroy it. You might also configure your admission controller to say, hey, I'm only going to pull an image from the production registry once I can validate that there is an acceptable vulnerability scan that has been completed. And that gives you some powerful tools to kind of automate some of the security with respect to deploying your containers. That's a really powerful thing to have in your toolkit. It can be sort of complex. Some of the larger organizations and dev shops in the container space already use admission controllers for other criteria, but we haven't seen a lot of activity related to admission controller technology specifically for security. Again, I think that's something that is absolutely going to change over time. So let's go back to the registry for a minute. I mentioned this before, but the registry segment of this process is where 99% of folks doing vulnerability scanning are operating. If you've got a tool like JFrog Artifactory, Red Hat Quay, or Docker Registry 2, all of the tools that we see out there common in the marketplace can talk to those registry systems. And what that means is they can actually intersect with the registry. They can scan images that have been published there and give you a report back on, hey, what vulnerabilities do I need to be concerned about? And typically you can get that in the form of some kind of a live dashboard. My screenshot here is showing a view into Qualys's container security tool. And so you can look at all the different registries and the images within there and produce many different reports showing, hey, where do we have the highest number of vulnerabilities and what are their severity levels and what things do we need to take action on? So it's a really powerful capability. Again, as I said, a lot of organizations are doing this whole staging versus production registry. And I highly recommend that you adopt that model if your organization can do so. One thing that's kind of interesting to me about containers is, when the container technology was first becoming popular, there was this assumption that containers only existed for a matter of minutes or hours, that they were always coming and going and becoming destroyed and repopulated based on supply and demand and actions in the cloud. And that isn't really as true as I initially thought that it was. In fact, a 2019 study from Sysdig showed that half of containers out in the production environment are only updated, weekly or less, which means that there is a continued opportunity for vulnerabilities to be introduced. If you've ever done anything with vulnerability management, you'll know that new weaponized attacks, proofs of concept, and vulnerability exploits are published every single day, in some cases thousands of times per day. And so if you think about it, a week is a pretty long time on the internet, and there are many opportunities for new vulnerabilities to be introduced and therefore resident in your running container space without your knowledge. And that's why it's really crucial to understand where are the opportunities that I can look for these vulnerabilities, detect what they are, and make a plan to get them fixed. So the idea in the grand scheme of things here is to scan throughout the container lifecycle. So you want to try to shift left to try to scan systems within your CI/CD build process so that you're catching vulnerabilities early before they get published into the registry. But you also want to scan images in your registry. Remember, these are candidates for deployment. So you want to make sure that the systems, that the software packages in your registry are as secure as they possibly can be. There's no reason to also not scan your running containers. Like I mentioned before, things like container drift, the population of rogue containers that you maybe didn't think about managing can all happen to you. And so it's critical to understand what vulnerabilities do I have in my running production environment at any moment in time. Definitely make use of Kubernetes admission controllers if you possibly can. There's a lot of great research out there that I'll point you to in a little bit that can tell you more about how to set up a container admission controller, Kubernetes admission controller, and how to properly manage that. And then last but not least, the final phase, continue scanning your hosts. Everything that I've said today about vulnerability scanning strategies for containers is important, but you can't ignore the host infrastructure as well. All of your cloud systems, your infrastructure components, they can have vulnerabilities as well. And so the traditional vulnerability management tools in the marketplace today can help you in that space, and you should continue to do that. So the message here is test early and test often. To the best of your ability, deploy these different strategies that I've outlined at every phase if you possibly can. Sometimes that's going to be cost prohibitive. And again, each organization needs to decide, what's our threshold? What does our budget look like? Some of the things I talked about before, what tools have we already invested in? And does that have an impact on what container scanning tools that we pick? There are a lot of great open source choices out there that might augment some investments you've already made. So let's get into some product comparison. And I want to make a few notes about that before we dive into the individual tools. These are really important things to consider. Not all of these products are equal. What I mean by that is they have different capabilities. So just to give you an example, Qualys, one of the tools that my team works quite a bit with, is actually delivered as a Docker image. So if you're not using Docker, well, guess what? Qualys is not going to be a great choice for you. The Tenable product, which is a really, really popular and powerful vulnerability scanning tool, can only scan registry images. Now, I suspect that's going to change because, in fact, Tenable's starting to make some acquisitions in this space to enhance their capability. But right now, they are only able to scan registry images. And so if scanning your running containers is a crucial aspect for your organization, well, then maybe Tenable might not be the best choice for that. A lot of different products that I'll share with you have open source equivalents, but also commercial flavors of those tools. And so what you will see is the tools that fall into that space maybe have some different capabilities for their commercial product compared with the open source system on which they are based. And remember that some of these products aren't necessarily compatible with all Linux containers. I've seen a couple of products that seem to be sort of like Azure or Google Cloud specific, but that's really not a huge consideration, but it's not a zero consideration. And then my second important note is some of these scanners, in fact, the majority of them, actually have trouble with distroless containers. Now, I just got done saying 20 minutes ago that you might want to consider a distroless container image as part of your build process. And again, what that means is you're talking about a container based on a super slim operating system that may have a lot of the traditional OS components removed. And the reason that that's a problem is many of the vulnerability scanner tools I'm going to share with you in just a second, they depend on things like the package manager to be able to enumerate the different versions of software libraries and code and stuff that is actually in your container image. And so if you take that out, all of a sudden you've lost a lot of capability. So keep that in mind as we look at what some of these products are and what they can do. So I've put together a matrix of some of the most popular vulnerability scanning products for containers. This is not a fully exhaustive list. I have to put together 10 slides to show every single product in the marketplace. These are the ones that I've researched as being the most popular, the most common, the most capable. And I've tried to identify which ones have an open source component versus a commercial component. So in my little chart here, if you see a red dot, that means yes, this tool can do that. So across the first line here, Anchor is a very popular tool. It can scan your CI/CD pipeline. What that means is you can actually integrate that with JFrog or with Jenkins to scan code before it gets published as a container image. It can scan the registry, but it can't scan running containers and it can't scan hosts. And so you'll see the varying capabilities of some of these tools. They're not all exactly the same. But as I mentioned before, you can see that I've put a red dot for every product under scans registry. All of these tools, Anchor, Trivy, Atomic CLI, Claire, they all can intersect with your registry and help you detect and identify vulnerabilities within that space. So that's good. The little circle that's like half gray, half red, what that means is there is a component that can do that capability, but it might either be the open source piece or it might be the commercial component. So that's a really critical consideration when you think about selecting some of these products. I am going to make this presentation available to everyone after. Of course, there's going to be a replay thanks to the CarolinaCon folks. So don't worry if you haven't been able to take a screen cap of this. I'll make it available to you later. Let's talk just briefly about compliance. Anytime you're talking about looking for vulnerabilities, it's important to consider, are there any compulsory things that I need to worry about from a security compliance viewpoint? And the answer is yes. Yes, there is. There are several different container-related compliance frameworks that are available today. Some of them are merely helpful in terms of advice and best practices. Some of them are absolutely required. I really, really like NIST Special Publication 800-190, which is titled Application Container Security. It's a great NIST document that can give you insight into how do I go about securing my container environment in my development shop. And it talks specifically about managing your container images. It specifically talks about scanning those images for malware and other things, but it definitely focuses on minimizing the attack surface, which we talked about a few minutes ago. One of the kind of interesting things about the NIST document is it gives equal weight to scanning systems in the registry and monitoring your runtime vulnerability load as well. And I thought that was kind of interesting. They're leaning towards the model that I put forward, which is to scan in every phase of that cycle if you can. Some of the other compliance frameworks like PCI and FedRAMP and even the GDPR for considerations for European data processing. They all talk about different requirements associated with specifically scanning containers. One of the things that I thought was really interesting is FedRAMP specifically talks about inventorying all of your containers and scanning all of the registries on a monthly basis. Frankly, I would say you need to do it a heck of a lot more frequently than that. But just keep in mind that one of these compliance frameworks may very well apply to your organization, and it's important to be familiar with what they require. So in summary, a couple of conclusions for you. Containers, although they're supposed to be unchanging, actually are made up of multiple complex layers, and each of those layers can have potential vulnerabilities. And that's why it's critical to extend your vulnerability management program into the container space. Um, Vulnerability management for containers really requires you to shift left, to push as close to your code development cycle as humanly possible so that you can fix vulnerabilities cheaply and more rapidly than you would do in a production environment. There are lots of opportunities, as I've described, for scanning sort of throughout the container pipeline. And that's important to find system weaknesses and eliminate them before you get bit in the fanny. The marketplace that I shared a minute ago has a pretty decent blend of both open source and commercial software tools that really can almost work in any environment. There's a lot of choices to be made on what tools right for your organization, but I hope I've armed you with enough information that you can begin that investigation. And then finally, compliance and demonstrable controls, that's never going out of style, right? We always live under the framework or the umbrella of security compliance, and the container space is no different. So make sure that you understand what regulations, what requirements apply to your company or your organization. A couple of takeaways for you here. My advice, build minimal base images. If you can use a distroless image and still successfully scan that image for vulnerabilities, do that. Use trusted software sources. Be cognizant of the limitations of the choices that you're making. Second, maintain all of the tools, packages, and libraries that you put in images. Let me tell you, anything you put in a container image, that's your baby, and you have to take care of it. You got to feed it, change its diaper, make sure it grows up to a successful adult. One thing that's actually kind of new in terms of maintaining container images is this concept of software bills of material. So about a year ago, President Biden issued a presidential executive order that is requiring federal government organizations and entities to maintain a software bill of materials that is basically a listing of all the different components and their sources that's going into your software package. This was something that came out of the SolarWinds breach a little more than a year ago. SolarWinds perhaps didn't have a complete understanding of where they were getting their different packages that they were compiling into their software products. And so as a result of that, it's becoming more and more important to focus on software bills of material. There's a tool from Anchor called Sift, and another tool that you may have heard of called Trivy that's made by Aqua Security, well, commercially supported by Aqua. And those tools now have the ability to index your container image and basically barf out a software bill of materials. And so that's a really important factor you may want to consider, especially if you're obligated to follow that presidential executive order. Third takeaway, make sure you carefully select a vulnerability scanning tool that matches what your organization is doing today. If you are specifically focused on open source software, you may not want to choose a commercial product, especially if you have sort of a tight budget. But if you've already invested in a commercial product for traditional infrastructure vulnerability scanning, it might make sense to use that same company's product for container management. Make sure that you're planning to implement vulnerability scanning at every phase of the software development lifecycle, or the CI/CD pipeline. All of those points along the process introduced opportunities for vulnerabilities to be attacked, and it's crucial that you apply as much oversight to those points as humanly possible. And then finally, consider some additional controls. I talked a little bit about staging registries. I mentioned Kubernetes admission controllers. We're starting to see more and more capabilities added to development shops that give them a better mechanism for control of their containers and for detecting security vulnerabilities. So keep an eye on this space. Make sure you're staying up to date with what these tools can bring to your team. That's all I have for you today, friends. In terms of references, as I put this presentation together, I came across dozens of really great resources. And so I have published this presentation to my GitHub repo, and in that same repo, you will find a bibliography document that has, like I said, dozens of links that'll give you a ton more information. So if you're interested in this topic, if you want to read more about it, definitely check out my bibliography to get some more information. Thank you so much. I again, really am appreciative of the 49th Security Division and the CarolinaCon organizers. Thanks a ton for having me today. Thank you.